Hello and welcome to Getting the Right Amazon Virtual App or Desktop. My name's Andrew. I'm a Specialist SA for End User Compute at AWS. I've been with AWS for about 3 years, and prior to that, 20 years in working with desktop virtualization solutions. So what are our objectives? I'll start with a quote, if I may. The ultimate measure of a man is not where he stands in moments of comfort and convenience, but where he stands at times of challenge and controversy. So said Dr. Martin Luther King Jr. That's a lofty quote for what I thought was a talk through of a simple feature comparison. Now, while there is comfort and convenience in the pay-as-you-go managed service, there is a challenge and occasionally controversy in matching the service to the use case for the business. When to reuse, when to rebuild, when to integrate, when to start again. With Amazon EUC services, Amazon AppStream 2, Amazon Workspaces, customers ask which of the options available will be right for their use case. This, my friends, is what we're going to talk about today. The key goal is to help you understand the right questions to determine which service or services you are to deploy. Help you look again at the business, see where you can experiment on making a change. In 2018, Jeff Bezos spoke about not undertaking experiments cavalierly. Our objective is to help make the goals that you have for your virtual app and desktop delivery to be good bets. Now, if there are parents in the room with more than one child, you likely face challenge and controversy when asked, which is your favourite? As an EUC specialist, I have a similar dilemma when asked about Amazon end-user compute services. Now, there are similarities between Amazon AppStream and Amazon Workspaces. Both fully managed cloud services. Both allow you to deliver rapidly for scale. Both offer high security and control. Both have a dedicated instance for users. Each user has their own AppStream or Workspace instance. There is no sharing. A user per instance is the most cost-effective model to allow cloud scale out and scale in with the highly reliable security and control you expect from AWS cloud services. Key for Workspaces, persistent desktops in the cloud. We've got Windows 10 experience desktops, Amazon Linux 2. Customers can bring their own Windows 10 licenses. Users can rebuild or restore a workspace if there's an update or an issue, but typically, when they log off or disconnect, when they come back to the workspace, it will be the same configuration as they left it. There's caveats for patch updates while they're away, of course. Now, key for AppStream, non-persistent applications. And now desktops, indeed, in the cloud. AppStream can be used to just deliver an application or applications if you've a suite or one app needs another. Maybe you've a CRM application that will launch an email service. The application environment runs in an instance as part of a managed service. AppStream can also deliver full desktop experience. Once a user logs off an AppStream session, the instance they were working on is removed, it's deleted. Starting a new session starts a new instance as if it was a fresh install. Always that new car smell. Now, if we consider use cases, it's tempting, because I've seen it done, to rigidly categorize use cases as persistent or non-persistent, and ergo forever. Use case X is always a workspace solution, and use case Y is always an AppStream solution. Now, as exciting as it always is to dive in, pause, take a step back. Ultimately, you have a business scenario, a profile use with application and access requirements, operations management and service capabilities, as well as compliance and security requirements. It is not always as simple as if this, then that. So now your question is likely, how do you go about understanding that? The key is to ask questions. Don't stop at a high-level use case, but dive deep into the requirement of what the application use is, what the existing deployment environment is, what the business goals are. Selection options can change with the understanding of the layers of requirements. Ultimately, we're moving to the cloud. I'd recommend to be guided in your questions by looking to the goal, by adding some challenge, maybe even some controversy for sure, but focusing those questions on and around AWS well-architected principles. Now, a common start question might be, does the customer need AppStream or workspaces? Or, we are use case X, what's the best practice here? Look to work through deeper dive questions. Now, we can't cover every question for every situation in this 30-minute slot, but there is no compression algorithm indeed for experience. Still, what we will do is look at principles and common questions to help guide you through a selection process for your use cases. Creating technology solutions like EUC services, like AppStream, workspaces, is a lot like constructing a physical building. If the foundation is not solid, it might cause structural problems that undermine the integrity and function of the building. If you neglect the 5 pillars of security, of reliability, performance efficiency, cost optimization, operational excellence when architecting technology solutions, it can become a challenge to build a user compute environment that delivers functional requirements and meets your business expectations. In addition, consider the well-architected principles helps ask the question, can we do better with this new service than we do today? So for operational excellence, that's the ability to run and monitor systems to deliver business value and continually improve supporting processes and procedures. Operational design principles include looking to perform operations as code, to design workspaces, AppStream services, to allow components to be updated regularly with minimal impact to the users. Key questions include requirements for application operating system. Understand the application or use case requirements. Are you providing a new service to users who need a remote Linux environment? Are you migrating from a shared service that has an operating system deployment model based on servers? Does your operating model or application environment mandate having Windows 10 Desktop Edition? As you refine your operations procedures to include use cases and workloads you couldn't accommodate or must accommodate, consider the OS baselines that are required or demanded. What's our deployment model use case? How are you rolling out applications today? What tools are you making use of? Is your operational model aligned very closely with tooling that you have today? Integration with tools like ZenWorks, Puppet, SCCM, or AWS Systems Manager. So you want to operate the same application management model, but with a more flexible approach to accessing that environment remotely, securely. Or have you had difficulty integrating applications into that tool set? Or maybe you don't have a tool set. What monitoring service are going to be used for the use case? Consider how often and what you monitor within sessions, application logs, performance metrics. How do you collect performance information today? Is it something you want or need from a new environment? Where is that data stored? And who will access it for trend analysis or troubleshooting or both? When considering operational excellence, key selection points, differences for AppStream and workspaces include what you see on the screen. In terms of requirements for application operating system, AppStream 2 does support 2012 R2 and Windows 2016, Windows 2019. With workspaces, you have Server 2016, Windows 10, and Amazon Linux. So Linux deployments will be workspaces today. Same if you must have Windows 10. Here, with Windows 10 Desktop Edition, you can bring your own license to Workspace. If you must have Server 2019 today, AppStream. Now, if it's Server 2016, you have a choice of either AppStream or Workspaces. In terms of deployment model use cases, AppStream instances are non-persistent. Each new instance is created from a defined base image. You don't need a desktop management tool. All the apps are configured as part of the base image. That allows the users connecting to be up and running as quickly as possible. With AppStream 2, you can deliver an application that perhaps needs manual or complex configuration steps because you can do that complex install once and have it delivered many times consistently. AppStream does support full image lifecycle management, so if your business goal is to have regular and rapid updates of an environment build, AppStream can help. When you update a fleet with a new image, as new instances are created for users to use, those new instances are built from that new image. As you create scaling policies, consider that when a new instance is created, it takes approximately 10 or 15 minutes to be available for users to use. Now, workspaces are deployed from a bundle. A bundle is a base image and an instance type. You can, customers do, customize the base image to create custom bundles. That said, workspaces are persistent. They offer a flexibility of configuration and can be managed as you've been managing desktop environments today. Similar tools, similar skills. Many customers deploy a base image with their common components, management agents, common tools. Then they use existing tooling that they've been using for their desktops today, like Puppet, ZenWorks, SCCM. As they transition to virtual or maintain both, they operate their same application deployment model, but with a more flexible approach to accessing that environment by using workspaces. From a request to launch a workspace to be provisioned, it's about 20 minutes. Can be longer if encryption is enabled or if Active Directory policies are applying additional configuration settings. If I want to rebuild or restore an image, consider that rebuild process is about 20 minutes for each workspace. They can be deployed, updated concurrently. In terms of monitoring services, both Workspaces and AppStream allow CloudWatch events for service health, instance counts, capacity numbers. Both services support installing agents. These could be third-party tools or AWS native options like Kinesis Firehose Agent to gather in-session metrics and logs. That data will be persisted within a workspace as workspaces are persistent, although you can forward to a central store, a central database. You could opt to store in workspaces and review from there. That's still entirely valid. Still, there are benefits in having a central store for visualization and analysis. For an AppStream instance, you need to actively extract that data to a central storage repository. You must log externally as the instance will be terminated on session end. For AppStream and workspaces, consider the cost implication for this operational excellence. Is it continuous logging or just logging when an event or an ask from a user is initiated? There are costs associated with storing data. Security. Security, the ability to protect information, systems, assets, while delivering business value through risk assessments, through mitigation strategies. Security design principles include implement a strong identity foundation, implement principle of least privilege, and enforce separations of duties with appropriate authorization for each interaction with your AWS resources. Look to centralize identity management and aim to eliminate reliance on long-term static credentials. Protect your data in transit and at rest. So when considering your environment, what methods of authentication are required for the use case? How are users authenticating to services today? Must you integrate with Active Directory? Are you moving to or have moved to different identity provision? And as you move to cloud-based services, do you want to continue to rely on Active Directory? Do you need to serve customers and want to integrate with a range of identity providers, say Facebook or Google? We work with customers who have a range of security requirements that require validation, inspection and qualification of the end device. Do you need that? When we consider encryption of data, obviously security is our number one focus. So what are the use cases for your encryption requirements in transit for at rest? Now, in terms of integration with identity and access management profiles, an IAM role, identity access management role, specifies a set of permissions that you can use to access AWS resources. This role is not uniquely associated with one person. Instead, it can be assumed by anyone that needs it. Can security principles be held in a session, or is there a mandate for an IAM profile use? Now, when considering security, key selection points, differences for AppStream workspaces include the following. So if we talk about authentication, both AppStream and workspaces integrate with Active Directory. Customers can connect their AD to AWS via Direct Connect or VPN, or extend their AD into AWS, or make use of managed AD. Workspaces must be domain joined. Now, AppStream can operate without AD. You can integrate with SAML2 identity providers if you need to. If you need to support wider SAML-based authentication methods, you can integrate AppStream to application launch into portal environments. You can validate users prior to them launching applications. As I say, Workspaces requires Active Directory. With Workspaces, you can extend authentication to validate the user's device. Workspaces supports trusted device access by requiring certificates to be installed in Windows devices or on Mac OS. Workspaces can limit endpoint access using IP security groups. Workspaces can also not allow different client types. Now, Upstream will rely on an identity provider to provide this level of functionality. Workspaces supports authentication with multi-factor authentication, and this does require Radius to be deployed. For multi-factor authentication with Upstream, again, use identity provider's MFA capability to provide that additional layer of security. In terms of encryption, both services encrypt data in transit from the instance endpoint to their instance type via streaming protocols. If you have a requirement for encryption of data at rest, Workspaces has 2 drives, operating system and a data drive. You can encrypt both. With Upstream 2, the data can be abstracted from the instance, stored off the instance on an encrypted shared volume, but the operating system disk image, which is transient, it's deleted on session end, that can't be encrypted. So when considering security, key selection points differences for Upstream Workspaces include authentication, methods of authentication for the use case. Now, both Upstream and Workspaces integrate with Active Directory. Customers can connect their AD to AWS via Direct Connect or VPN, or maybe even extend their Active Directory into AWS, or make use of Managed Active Directory. Now, Workspaces must be domain joined. Upstream can operate without Active Directory. It can integrate with SAML2 identity providers. If you need to support wider SAML-based authentication methods, you can integrate Upstream 2's application launch into portal environments. You can validate user auth prior to launching applications. Workspaces requires Active Directory. With Workspaces, you can extend authentication though to validate the user's end device. Workspaces supports trusted device access by requiring certificates to be installed on Windows or Mac OS before users can connect to their workspace. Workspaces can limit endpoint access using IP security groups. Workspaces can allow or not allow different client types. Upstream relies on the identity provider to provide this sort of functionality. Workspaces supports authorization with multi-factor authentication. MFA with Workspaces does require Radius to be deployed. For MFA with Upstream 2, use your identity provider's capability to provide that additional layer of security. For encryption, both services, both Upstream and Workspaces, encrypt data in transit from the instance to the endpoint using their streaming protocols. Now, if you have a requirement for data at rest, with Workspaces, you have 2 drives, operating system and a data drive. You can encrypt both. With Upstream, user data can be abstracted and stored off the instance on an encrypted shared volume, but the operating system disk, which is transient, it's deleted on session end, that's not encrypted, but it's deleted on session end. You can't access the data. In terms of integration with IAM profiles, you might ask, can you use IAM profiles to allow users to manage Upstream or Workspaces instances? Yes. So you can give support teams ability to, say, restart a workspace, for example. Now, applications and scripts that run on Upstream 2 streaming instances may be running AWS API requests. You can create an IAM role to manage those credentials. The IAM role specifies a set of permissions that you can access, that you use to access AWS resources. Now, this role isn't uniquely associated with a person, however. Instead, it can be assumed by anyone that's using that Upstream instance. Workspaces doesn't have the ability to be assigned an IAM and identity and access management role today. So another pillar, reliability. Reliability is the ability of a system to recover from infrastructure or service failures, dynamically acquire computing resources to meet demand, and mitigate disruptions such as misconfiguration or transient network issues. When we consider reliability, Consider autonomy of users. For many use cases, the end user simply wants to use and consume the application environment. Now you can extend that to have requirements to have a fresh environment for every session start, maybe for compliance. If there is an error, because everything fails all the time, what's the recovery time? Or perhaps the use case requires autonomy for users. There may be a base build, but they need to install different applications based on role or function. And maybe that's from a predefined corporate application store or from the internet directly, if that flexibility is required. What are the end user network latency constraints? Key for any end user compute service is the user experience. When you look at the use case for your user profiles, where are the users in relation to AWS regions that support the UC services? What bandwidth network capability do they have available? And then requirements maybe as part of disaster recovery or business continuity. It's a very common ask if customers, especially if customers have an on-prem environment and they want to use cloud for DR for business continuity. Or they have resources in a cloud region and want assurance that there's an alternative because everything fails all the time. So what are the requirements around speed of provision? Given it's maybe business continuity specifically, does it need to be exactly the same configuration as a production environment? And if you've got this additional environment, how is it managed and maintained, kept up to date and validated, tested? When considering reliability, got key selection points differences for upstream, workspaces, do cover autonomy. Both workspaces and upstream have the concept of image builds. I, as an administrator, I can predefine the environment a user has. Now that said, with upstream, users could attempt to install applications or mess with the configuration, or maybe they just have an issue. If their working environment corrupts, terminates, log off, log back on again and get a new clean image with no errors. Very quick fixed time. Time to live, about 2 minutes. That said, if I want to apply a patch, I can create a new build, but I need to apply that to the fleet so that on next logon, there's an image available for new users. There's an image update process for that. Workspaces allows flexibility. Users can make changes, be local admins if need be. With that power, obviously, comes responsibility. If a workspace is corrupted, users can restore or rebuild a workspace, but that's a 20-minute plus operation. If I want to apply a bundle update, I should apply in phases out of hours, as it could be 20 minutes operation per workspaces. As I've said before, workspaces can be updated concurrently. In terms of end user network latency constraints, there is less of a capacity restraint for scale out with cloud services or over traditional VDI, but there's still a consideration for bandwidth requirements for end users. Workspaces can operate with lower bandwidth requirements than for standard instances than for upstream 2. That's tempered with the fact that for upstream 2 workloads, often they're more graphic intensive, which has a higher demand. With upstream, you can use VPC endpoints for streaming traffic. Now, with this feature, the network connection between your users and your upstream streaming instances and your API operations can be restricted to private network routes and can help further secure your applications and because the streaming traffic is routed across your network connection to AWS. Now, with workspaces, the workspaces streaming protocol is designed to give a good user experience over higher latency networks. Do test and validate for your users and site locations. In terms of DR, if it's for on-prem DR or DR in another region for an existing AWS workload, consider with workspaces, you need to build out or at least have instances ready to be deployed. With upstream, you can define a maximum fleet size, which will scale using scaling policies as needed during a DR event. For both, ensure that you've the quota limits and IP address allocations in place to accommodate a DR BC scale out event. Now, obviously, DR is not just about remote application desktops, but about the supporting environment as well. So services that they connect to. That might be Active Directory, it might be databases, it might be file storage. In terms of performance efficiency, That's the ability to use compute services efficiently to meet system requirements, maintain that efficiency as demand changes and technologies evolve. So from an end user compute point perspective, that's end user device integration requirements. It may come as a surprise, but EUC services rely on end devices. When you're asking your deep dive questions, what are the requirements, specifically on and around device support? I've picked some key ones here: printing, camera, card reader. What are application hardware requirements? For your use case, what are the specific requirements for the operating environment? CAD applications, for example, can be very specific on the GPU type and how much memory they've got access to. And how to use the global scale of Amazon EUC. From an end user perspective, performance is about how they interact with the service. So you're looking to provide a secure environment for your end users to work in there, and their experience shouldn't be hampered by their location. So which regions, which Amazon EUC protocols are going to deliver that best user experience, that great user experience that helps them make best use of the service. So when considering performance efficiency, let's look at selection points, key differences for AppStream and workspaces for performance efficiency. Let's consider that end user device integration. All services, both services, workspaces, AppStream, support, cut and paste, both have policies to enable or disable that option. Then it gets more exciting. With AppStream, there's support for upload, download of files. If you need local drive access, perhaps, both the web client and the AppStream Windows client support this. With the Windows client, you've native application support. So apps appear as apps within your desktop environment, your Windows environment. You've also got USB, storage pass-through, and printer redirection. AppStream also has support for browsers, HTML5 browsers, so that's Edge, Chrome, Firefox, Safari, as well as the Windows AppStream client. Now, with workspaces, there's support for native clients, so Windows, Mac OS, Android, iOS, Linux, Web, Zero clients. Workspaces supports local printer redirection. For workspaces streaming protocol workspaces, you've card reader support, and webcam support is, as I speak today, in beta. Bear in mind, workspaces users get 50 gig of WorkDocs use to allow file transfer. Now, in terms of application hardware requirements, AppStream has over 30 different instance types, including G4. There are large memory instance types for applications that require a large amount of memory. Workspaces are more focused with 7 different instance types. Now, I've customers finding specific applications with demanding hardware requirements are going to AppStream, where there's a more flexible fit for instance types. And when we talk about AWS on global scale, as you can see, there are regions available for AppStream, regions available for workspaces. These are, as I speak to you today, do check the website for updates. Now, in terms of cost optimization is the ability to avoid or eliminate unneeded cost on or around suboptimal resources. It's a measure of the overall efficiency. Measure the business output of the workload and costs associated with delivery. Now, you use that data to understand the gains you're making from increasing output, increasing functionality, and reducing cost. So for an EUC environment, that could be end device reutilization or migration. Which devices are going to be used? Are you going to use thin clients? Are you going to use zero clients? Are you moving to a bring your own device model? In terms of concurrency of use, with AppStream and workspaces, as I've mentioned, one user, one instance. That's the best model for cost-effective cloud scalable architectures. You can scale out rapidly, but also scale in, helping to deliver that pay-as-you-go model. Reduce costs by not over-provisioning resources that you typically have at a traditional VDI deployment. How are users using the environment today as you consider different use cases? How are users consuming or need to consume those resources? In terms of use case usage profile, that's aligned to concurrency. Consider the user profile to plan efficient scale out and scale down policies? Is instant access required when users launch sessions? When are users using the service? Because, all right then, so now we understand cost optimization key items. So what are the selection points, differences for upstream workspaces? Consider requirements for concurrency. With workspaces, you have to deploy a workspace before users can use that workspace. So always look to integrate to a joiners or leavers program to not only provision workspaces in time, but remove workspaces instances if they're no longer needed. Upstream fleets can expand and contract the size of a fleet to a user demand. Shift working, for example, is well aligned to an upstream model. If I have 900 workers in 3 shifts, with upstream, the maximum users of instances is the number for that particular shift rather than all of the users together. The scaling policies ensure that you're only paying for the resources as they are required. In terms of end user device reutilization or migration, ask questions on end devices. If you have an existing investment in zero clients or thin clients that support PC over IP, workspaces. If you more generic device access, web access for workspaces, or indeed upstream to using a web browser to deliver access can be considered. Upstream 2 doesn't require workspaces, and upstream using web access doesn't require dedicated client install and can operate over port 443. We consider the use case usage profile. Workspaces, upstream, both support always on and on-demand usage. With a pay-as-you-go model, there's choice. Always on gives you instant access, but can be more costly than on-demand, which has a lower cost. Ultimately, with cost optimization, we start with a premise and iterate. For upstream, consider the use profile to plan efficient scale out and scale down policies. Have buffer instances available to make sure there's always capacity for users logging on. Review that usage and modify fleet scale policies as required. Now, workspaces users can self-serve to move between workspaces compute type or indeed increase the size of the disk space. This allows you one method to allow you to match performance to workload. Some might change over time. This means you're right-sizing the workspace performance and not incurring cost through over-provisioning. You can guardrail this so there's authorization of requests before changes or actions. Also, I'd recommend using Workspace's Cost Optimizer to find the most efficient running method, whether it's always on or auto stop. With Workspace's Cost Optimizer, you can either report or automatically change the running mode so your workspaces are operating in the most cost-effective way. In our deep dive, you may consider that it's one or the other for upstream or workspaces, but do bear in mind that as we deep dive into use cases, we can find that either upstream or workspaces is most appropriate for that use case. As we combine use cases, we can often find that customers find that upstream and workspaces can work together to help them deliver business functionality. Maybe, as you can see in the diagram, we're providing access to standard or maybe performance desktops. And then what we want to do is enhance the environment using upstream 2 instances, maybe to provide specific secure applications that need different access requirements. Here we can combine upstream 2 Windows client to make that upstream 2 application appear natively within the Windows desktop. The remoted application acts and behaves just as it would do as if it was running locally within the environment, but it's running remotely in the upstream environment. So in this example scenario, using our well-architected principles, we've deployed Workspace as a standard desktop service to enable productivity apps, standard line of business apps for all users. But internet connectivity is restricted and available only to some users, and the security team has defined access must not be enabled directly from the working environment. So there's a requirement for some users to have occasional access to the application that requires a GPU. Here, with upstream, using the Windows client can be able to abstract the application. So you've got a common workspaces environment to provide application delivery and then optimized and secured using upstream. I hope you can use the comfort and convenience of these well-architected principles to help you with the challenge of making good EUC life choices. To help your users, to help your customers, take this information and iterate and build on it. Still, if your proof of concept, your pilot, doesn't work out, to paraphrase Nelson Mandela, you never lose. You either win or you learn. Now, as a member of the Specialist SA team, we're here to help you to that win. And for wider learning and understanding, I leave you with the links to useful resources with regards to best practices for configuration and deployment. I would recommend a review. I hope you've done both learning and winning today. I thank you for your time. My name's Andrew. Good luck with your future projects.